All right, due to popular demand, I am back with another video. Today we're going to be talking about SOH-CAH-TOA. SOH-CAH-TOA is a very helpful thing to remember certain trig functions. So let's go over it real quick. SOH-CAH-TOA stands for sine equals opposite over hypotenuse. The ka means cosine equals adjacent over hypotenuse, and TOA means tangent is opposite over adjacent. Okay, we're going to use this in our problems today. So let's take a look here at our first problem. Let's say that we had the following triangle, and we need to solve for x. Well, to use SOH-CAH-TOA, we first need to make sure we have a right triangle. And we can tell we do right there because that's 90 degrees. All right, so we have a right triangle. What we're going to use is we're going to use a side that's given to us and one of these angles. Guess what? You get to choose whichever angle you want. I'm going to go with 75. So I'm going to look at my 75. Now this x is what I'm trying to solve for. From 75 to this x, we can tell it's the opposite because I go all the way across. Okay, so x is my opposite side, and 8 is the hypotenuse because it's across from our 90-degree angle. So we have our opposite, and we have our hypotenuse. Which one of these has opposite and hypotenuse? We can tell right here, our so. So we're going to use sine. So right here, we're going to take sine of our angle, sine of 75, and it's going to equal, again, the opposite over the hypotenuse. Okay, in this case, that is x over 8. Let me change my brush there. Okay, here we go. X over 8. Okay, so we have the sine of 75 equals x over 8. To solve for x, I'm going to get rid of that 8 on that side by multiplying both sides by 8. So now 8 times the sine of 75 equals x. If you type that in on your calculator, I believe you're going to get 7.73 equals x if we round to the nearest hundredth. Now some of you are looking at this like, well, couldn't we actually have used this 25? Certainly could have. If we use the 25, we're going to have our x, which is now our adjacent, and the 8, which is still the hypotenuse. So we have our adjacent side right here, and hypotenuse, adjacent, and hypotenuse. Boom, we're going to use cosine. So cosine of our angle, cosine of 25, equals adjacent over hypotenuse, which, as we just talked about in this case, adjacent is x, hypotenuse is 8. So cosine of 25 equals x over 8. To get x by itself, we're going to multiply both sides by 8. It'll cancel out there. So we have 8 times the cosine of 25 equals x. If you type that on your calculator, again, you will get 7.73. So no matter which way you do it, you should get the same answer. Okay, let's look at another example here. Here we've got another triangle. It is a right triangle, so we can use SOH-CAH-TOA. We can use our trig functions. We're trying to solve for x, which is this side right here. We're given this side, so I'm going to use it. And we're given two angles. You can actually use whichever angle you would like. This time I'm going to stick with my 33. All right, so let's take a look here. We have this 33 and this x. If we're looking at this 33, the opposite side is right here. Well, that's not x. And we know our hypotenuse is right here, that 9. So that leaves x being our adjacent next to that angle. Helps form this angle right here, this side does. So we have our adjacent and we have our hypotenuse. Okay, which one is adjacent and hypotenuse? Looks like right here, ka, which means we're going to use cosine. So cosine of 33 equals our adjacent over hypotenuse, which is, well, our adjacent is x, our hypotenuse is 9. So we have cosine of 33 equals x over 9. To solve for x, multiply both sides by 9. So 9 times the cosine of 33 equals x. If you do that on your calculator, you're going to get 7.55 equals x. If you decide to do the sine of 57 instead equals x over 9, you will also get 7.55. Okay, let's take a look at another example. Okay, right here. Now this time, it's a kind of a combination of what we've been learning. We have x, y, and z. Ooh, a lot of different things here. I'm actually going to solve for them in that order. Okay, so we have a right triangle. I have my x. Well, we can actually just do good old triangle sum theorem. All the angles in a triangle add up to be 180. So we have 90 plus 28 plus x equals 180. We add these up and we get let's see here, 108. Nope, 118. Sorry guys. 118 plus x equals 180. Now many of you know it's a shortcut. Couldn't we just do 90 minus 28? Yeah, that would work. Subtract 118 on both sides, and x is going to give us 62. Okay, so there's x. Nothing too crazy. Let's see here. Now we need to solve for y and z. Okay, let's solve for y. I always like to use the angle and the side that they give me, just because they're usually nicer numbers than the ones we calculate. Not always, but sometimes. So I'm going to use this 28. If I use this 28, this y here is the opposite side, and 19 is our hypotenuse. So opposite and hypotenuse means we're going to use sine. So sine of our angle, which is 28, equals opposite over hypotenuse. To solve for this, all I do is multiply both sides by 19. So we have 19 times the sine of 28 equals y. Let's see here. I believe when you multiply that out, you will get 8.92 equals y. Okay, now we got to solve for z. Could we do Pythagorean theorem? Yes. However, if you're using y, you can't actually use 8.92 because that's our rounded version. We got to actually use the whole thing, which is a really long decimal. So I'm actually just going to use trig again. I'm going to use my angle that's given and my side that's given. I'm looking at z. If I'm looking at 28, z is the adjacent, and 19 is our hypotenuse. Adjacent and hypotenuse means that we will use cosine. So adjacent and hypotenuse, cosine. Cosine of our angle. So cosine of 28 equals z, our adjacent, over 19, our hypotenuse. Solve for this, all I gotta do is multiply both sides by 19. So we get 19 times the cosine of 28 equals z. If you type that in on a calculator, you should get 16.78 when you round to the nearest hundredth. Alright guys, that's it on basic trig. I'll also make another video in a little while that has to do with inverse trig functions. Alright, have a good day. Make sure you like, comment, and subscribe.